Good morning, good afternoon, good evening, everybody. Thank you so much for joining us today for our Tridium Talk and our Niagara 413 feature overview series. Today, we're going to be covering Containerized Niagara and our new subscription licensing offering. I am Mike Smith, product manager here at Tridium. We've got a very special guest joining us today, Robert Lastinger from Distech Controls. So a lot to cover today, so let's get started. On today's agenda, I'm going to briefly cover what's new with Niagara. I'm going to give a quick overview of containers and subscription licensing. Robert Lastinger is going to follow up with a live demo and show us some really cool things that you can do with Containerized Niagara. And briefly highlight some additional Niagara resources and materials, and we want to leave plenty of time at the end for Q&A. So a couple housekeeping notes as we get started. Everybody on the line should be on mute, but we will welcome your questions. You should see the Q&A button on your Zoom menu, so please feel free to drop a question in the chat anytime during this call. And joined today by some wonderful folks here from Tridium who will be answering those as they come in. Some we will highlight and we'll save for to answer live at the end of the call. All right. So what's new with Niagara? Our long-term supported release, Niagara 410. Many of you know 410U5 has been available for some time now. 410U6 is coming out next week, so make sure you keep an eye on your inbox and keep those stations updated, and reach out if you have any questions on our long-term support release. Niagara 413 is now in beta testing, so very excited about that. If anybody on the line is interested in participating and testing 413, please reach out to me. My contact info will be on the slide at the end of the presentation. So we're very excited about Niagara 413. It is jam-packed full of new features and functionality. I'm not going to read all of these out, but I would strongly encourage all of you to check out the additional Tridium talks that have been in this 413 series. My colleague, Chris Riccobono, has done a number of feature highlights on some of the great new things coming in Niagara 413. So on to today's topic, Containerized Niagara and subscription licensing. So this is a completely new offering with the Niagara 413 release. Wanted to start off with just an overview of what exactly is Containerized Niagara. Hopefully many of you on the line are familiar with Docker containers or what containers are, but for those of you who aren't, a quick definition of what a container is. And basically it's a way of running in a virtualized environment. But a container is a software package that takes all of the code dependencies so the application can run quickly and reliably from one computing environment to another. And a Docker container specifically is a full image that's lightweight, can run standalone in an executable package that includes everything needed to run the application, including code, runtime environment, system tools, system libraries, and settings. So essentially, we've packaged up the entire Niagara framework stack into a Docker container with all of its required dependencies for easy deployment. Now, we are coming to market with a 64-bit operating system. So as you start having these conversations with your sales rep and expressing your interest in it, just to highlight what we are supporting with this offering in the 64-bit architecture space, we have a container that supports ARM64 and AMD x86 architecture. So that's kind of be the first question as to what you're looking for. The second question is going to be which authorization model are you using? And we're offering support for file domain authorization and native domain authorization. And really the difference here is in file domain auth, this is interacting with the platform in the station, just like you would today. That's how you authenticate and connect to it using your standard Niagara credentials, username and password. The native domain auth model is more towards large deployments where you're using orchestration tools such as Kubernetes. You can put the credentials into what's called Kubernetes secrets and let your orchestration manage the connection and authentication with the container. So what isn't a Niagara container? There are some limitations to what is coming in this offering. Due to the nature of the container being virtualized and abstracted from the hardware that it's running on, you will not get your serial protocols. So this This offering will cover the IP drivers only, so none of the serial protocols and drivers will be enabled, such as MSTP. One requirement of the container is that all the containers and instances must have a constant connection to the internet. So this is enabling our subscription licensing. The container has to reach out to our entitlement server at least once or twice a day to re-authenticate and get its authentication token to continue running. So this is really a preventative measure on our end to prevent duplication and cloning of containers and reusing the same license to run multiple containers. The connection to the entitlement server is just a single URL API. It goes out, sends out a token, gets a refresh token, and continues running. And to cover also what it isn't, the container is completely headless. It runs a headless Java runtime engine. So you're not going to get Workbench with your container. It is, you'll need another laptop or PC running Workbench in order to interact with the container. And many of you might be asking, why would I use a container compared to a traditional Niagara deployment? Containers are much less resource intensive if you're going to run it in a virtual machine or a virtualized environment. They also lend themselves well to scalability, which can ease development, deployment, and pushing upgrades to the containers. So you can do this today with your standard Workbench and your standard Niagara stations through provisioning. This is just an alternative method to be able to do that and run at enterprise scale. So formally, many of you may be running Niagara stations and virtual machines on a hypervisor. These can be very resource intensive and have a lot of runtime and overhead. Where many in the industry in the IT space are moving to containerized applications, which have much less overhead and also offers the opportunity to run multiple applications on a single Docker engine. We primarily see three use cases for the containerized offering. That is in the cloud on a supervisor deployment in a cloud service, an on-prem supervisor where the container is deployed on a server housed locally on-prem, and also something that's very new and unique to us, what we're calling the hardware and embedded offering. So if you have a device that is capable of running a Docker engine and it has the resources necessary to run Niagara, you can then deploy Niagara container on third-party hardware. So historically, if you're running Niagara, you either had your Linux installer, your Windows installer, or you bought a piece of Tridium hardware or hardware from one of our portability partners that had Niagara on top of it. So this is not a one-to-one comparison to the portability offering, as I've covered the limitations, but it does enable Niagara to be deployed in new, unique, and different ways. And just a quick example of that, one of our early adopter and proof of concept partners has created a mobile hub with other applications running in containers. They really wanted Niagara on it and didn't have a requirement for serial protocols. So it was a good fit, and we've been very successful with the early access and proof of concept testing with them. So containers also offer additional value and flexibility. Again, if you're running in the cloud, there could be a potential cost savings versus standing up a server on-prem. So I don't have to invest in the server rack and deploying that way. Robert will highlight later how it scales and how it's a good solution for enterprise customers that are running, tens or hundreds or thousands of instances of Niagara. And then some of you may have customers with strict security requirements. They want to know what's running, what version is it running, what's the health of the container, and be able to instantaneously push updates to the containers. So using orchestration tools, it gives good visibility into that. So with the flexibility, Tridium is providing the Niagara container. We are going to push that to market through our OEM and distribution channel. And really it's on the reseller, the installer, the SI to determine how to deploy it, where to deploy it. So you get to choose your hosting platform of choice, be it Azure, AWS, Google, any of the cloud hosting platforms that support running Docker. And if you're doing enterprise scale, you get to choose your orchestration platform of choice. So there's a lot of differences between this and running traditional Niagara. It's got its kind of own base knowledge and skill set required. So if this is something you're interested in, make sure you're having conversations with us or experts like Robert at Distech to make sure this solution is a good fit for what you're looking for. And I briefly touched on subscription Niagara. The container is going to run in a subscription mode with 4.13. We are looking at other enhancements and purchasing options in the future, but we wanted to come to market with this to add a little more purchasing flexibility and roll out a subscription-based offering. So now you can go to your customers and offer them the ability to purchase on an OpEx model versus a CapEx model. So you'll have an annual recurring fee on this that will cover your license. And what's really nice about this is your software maintenance agreement is rolled into the cost, so you don't have to worry about that. You can always keep your containers up to date with the latest releases. And just a little highlight, so you've got Containerized Niagara running on-prem or in the cloud. And then it's got to have that persistent connection to the Niagara licensing server to make sure it enables its runtime. Just a quick highlight of some of the models that are coming to market with the 413. Again, both supervisor and what we're calling hardware embedded. On the left, you'll see on the top your supervisor based models ranging from 0 Niagara network connections up to 500. And then supervisor upgrade pack. So this is adding additional Niagara network connections to your base model. And then for those of you who need device connections to the supervisor, we're offering supervisor device packs. So 10 up to 1,000 devices can be connected to your subscription supervisor. On the right, on the top, you've got your base hardware embedded models. So that is 1 device connection all the way up to 200. And then additional hardware embedded device packs. So trying to fine tune the licensing model a little bit and give flexibility and the ability to add on to your base licenses as needed. Along with the base and the upgrades, we're offering a number of drivers and features that can be added to your license. These include our new Open ADR 2.0 driver, analytics packs, and we are taking the HTTP and JSON toolkit and combining them into a single SKU. We're calling that the API driver. So additional functionality, additional drivers can be added on to your license. I know I went through that quick, but again, I wanted to get through it so we'd have plenty of time for Robert and have a live demo with him. Robert, before we get started here, I just want to ask you a couple of quick questions. I know you love Niagara, and I couldn't find a picture of you on LinkedIn, so it's close enough.
That's intentional. That's intentional. I hide. So.
Robert, we've been working with you guys for probably over a year on this. You guys were, some of our early adopters. You've been doing proof of concept testing. Just wanted to pose a couple quick questions to you. And I want to see what your take is on the value and benefits of containerized Niagara versus our traditional offering. And I know you guys have also done some proof of concepts and some demos for some of your customers as well. And just curious what their feedback has been on this offering and also the new subscription-based licensing model.
Sure. Well, for a lot of our customers, I'll start at the subscription-based licensing model because I think that's probably one that's going to generate a lot of questions. And for our customers who are already in the cloud, this is a comfortable fit. They're already there. They're typically with AWS, they're Azure. And so they're already kind of in that model. And for them, there's an advantage to this because they kind of want the ability to scale up instances, to have Niagara instances, combine them or shed them. And this gives them that flexibility. In the traditional model, you would buy a supervisor with an SMA for an extended period of time. And that doesn't really work well if you only need that Niagara instance for a project or a short period of time, or maybe a year and a half or something like that. So the subscription model makes a lot more sense for the customers in that sense. And on the other note, portability is a big deal for them. A lot of them are already operating cloud, and it's very expensive to spin up a full-fledged instance, like a Windows instance or a Windows Server instance to run Niagara on. And now they can take a much smaller instance, get the same performance with the container, and also it's a lot easier to use it in different environments because it's platform agnostic. As long as you can run the container on any environment, you can choose a pick. So for our customers who have some pretty significant security requirements, this is a lot better. Plus, they can, as you're well aware, they can just scan the image for security, and once it's validated, they can deploy it anywhere within their infrastructure. So it can be deployed locally, it could be deployed on-prem, and the same image can be deployed in the cloud. So there's for a lot of our larger enterprise customers, this is a huge win for them. We do have some customers who are demoing this at the university level, and they're also these are customers who are already Linux, kind of a Linux shop, and for them, they can leverage their resources a little bit more effectively. They can run multiple Niagara instances on the same hardware without the overhead of a full VM. So for them, this is a big win as well, because they have a lot of small Niagara instances for individual projects, buildings, and departments. So I don't want to go too far into this, but we have some more to talk about. But were there any specific you wanted me to touch on, Mike?
No, that was great. I think you answered that wonderfully. Thank you. All right, so I'm going to turn it over to Robert. He's going to give us a demo on deploying containers, starting up a container, how you would go about scaling for enterprise solutions. He's got a good demo on some orchestration. And I know there's going to be a lot of questions on the new subscription licensing. So we want to make sure we walk you all through what that licensing a subscription instance looks like. So Robert, I'm going to turn it over to you. You want to take the screen and
all right, just make
away.
sure to interrupt me if I get lost or we get too fast or we need to slow down. But let me share my screen real quick. Let's make sure you can see it. So you've got my screen?
Yes, sir.
All right. So here, a lot of you would have seen this before, but we're going to start with AWS. There's no preference here. We just wanted to show deploying a container to the cloud in a kind of a straightforward, easy to duplicate manner. And we felt that an EC2 instance was a really approachable way to do that. And you can do the same thing in AWS or Google Cloud. This just happens to be, we've had some customers specifically request this. So today we're going to showcase it. And I'm going to use some commands I've saved here. And Mike, you guys can all email Mike directly, but you can reach out later and we'll provide these commands so that you can see what we've done here. Of course, we'll remove anything specific like the registry used, but we'll provide the commands so that you can follow along afterwards to do this yourselves. So on that note, we'll go ahead and kick it off. So I'm going to launch a new instance. This is an EC2 instance. So I'll just go to the wizard that they have. I'm going to select Amazon Linux here, and I'll select one with an SSD, because normally if you're going to do this, you probably want a bit of storage so that you can have a station running and you have some persistence going along. So we'll go down here. Once you've selected it, you'll notice it's 64-bit architecture. That's important since that's what's supported. They do have the ability to run ARM. We're not covering that today, but this does work as well. So if you need to test an ARM instance for one reason or another, you can select this. And then for instance type, we're going to select one that has a little bit more memory. I like to run. You can start the instance in a more constrained environment, and this is a good thing if you're maybe trying to also potentially have this run on hardware later that's more constrained. But for demo purposes, I like to give it about 2 gigs of memory. So we're going to select that one, and then I've already generated a pair of keys. If you haven't done this, you can just create a new pair here, and you should save these. So just for future reference, if you're using these on multiple machines, you're going to need these later to log in. And then for network settings, I've also gone ahead and created a security group. This is an easy to do step. And this is defining which ports are going to be available. And I'll show you later, but really we've only done 5011, 4911, and 8443 just for the demo. Okay, I'll give it maybe 30 gigs of storage for my test here. And that should be it. So we've selected one instance. T2 small, for those of you who are watching this again, trying to do it. I have a security group that's been created already called Niagara Network. And I'm adding about 30 gigs of storage just to give me some room to play. So we'll go ahead and launch this instance. It's pretty quick. So once it's successfully launched, you'll go to connect to instance. It should give you an IP to your instance here. I'll select that. And then from there, I should just be able to connect here. 1 second. We'll paste that IP in here. It takes a second to spin up, but go ahead and save that. And then let's see if we can connect. You got to give it a second to spin up. So hopefully we won't fail on this one, Mike. And there we go. The instance is now running. Okay, this is a clean Amazon Linux 2 instance. There's nothing that's default. Anybody could deploy like this. And I'm going to run some commands here just to spin this thing up. So first we're going to update it. Then we're going to install Docker. We're going to start Docker. We're going to enable the Docker service so that if the instance reboots, the Docker will come back up. I'm going to add my user to the Docker group. And then I'm going to log into the registry where we have the container. So I'm going to go do these all in one shot. So I'll just copy this whole thing like so. We'll paste this here. We'll hit enter. And we'll let it run through this real quick. And it's pretty fast. You'll notice even for a small instance, this will update everything it needs. It will install Docker, add us to the group, and then it will prompt me for the login for the registry where we have the Niagara image. And if you're doing this at home, you can spin up multiple instances at once. And depending on your tool set, you can run these commands against all instances. Amazon has a great CLI, and you can script a lot of this if it's something you need to do routinely. But we'll show in the next step, we'll show a Docker Swarm deployment, and that's a little bit easier to script, a little bit more fun. So here it's asking me for my login for my registry. So I'll go ahead and do that. Oops, I need to log in, log out, and log back in for that. So, we'll have to save this command as a separate step after login, since it requires you to have permissions. So here we go. Okay, login succeeded. So I now have access to the image on the registry. And from here, I can grab it like so. And so this is a standard run CLI, Docker run CLI. So you'll see here, I'm just going to make a folder under my account for the volume. And then I'm just going to do Docker run. And I'm going to, and these are documented in the PDF that you would pull off the website. But we'll cover these later. But basically, we're just declaring the 3 ports, the volume, the time zone, and the name of the container. And here's the registry that we're pulling it from. So we'll just paste this in.
And Robert, I did answer this in the chat, but now may be a good time to answer this live as
Sure.
well. There was a question about passing your configuration and parameters. So what Robert is showing is utilizing the command line to pass your container configuration and parameters in. You can also use Docker Compose and create a config.yaml file. So when you bring up Docker Compose, yep, there you go. So a couple different options on how you spin up the container and pass your parameters into it.
Even a third we'll show at the end here, which is the just the standard container deploy options, which don't look as pretty as this, but we can look at that one right here. And this is what the same command looks like in there. So you can see Docker Compose and Docker Run CLI are a bit preferred, even from not only from a visual standpoint, but just from an editing standpoint. These are a bit easier to work with, right?
Yep.
So, but we'll go ahead and deploy the container. So I'll grab this command, I'll paste it in one shot, and we'll hit enter. So it's downloading the image from my registry, and then it's going to, once it has it, it will spin up a container. And we should be able to access that container at the platform port. Okay, so one thing I can run here just to verify that the container is running, Docker ps-a, and I can see it says that the container is up for 7 seconds. And we can even look at the log files here if we wanted to. But we'll do that here in a second with a better visual in Portainer. But it's good to make sure before you step away from this, double check to make sure your container isn't just crashing. Because a lot of times you'll come back here and you'll see that if you've made a mistake, you'll see your container will say created 22 seconds ago, but your uptime will be 3 seconds or 4 seconds because it keeps crashing. So this happens sometimes if you get your deployment instructions wrong or you have an issue here. So it's worth double checking before you move on to make sure that your container is actually up and running for a period of time. And you can even do, I think it's And you can see here, this command, docker container logs, and then the name of the container. And I can see here what you would expect to see in your application director. You can see that similar output. You can see that you've initialized a container. And if you read on down here, we can see that everything's gone well and the startup is complete and it's now ready for me to connect on the platform port. So from here, I would just want to grab my my IP address of my container and type it in my platform. So let's see, it's 3.7.210.146. Okay, so we'll go ahead and go to my workbench, file, open platform. And that is, what was that? I've already forgotten it. It was 3. Okay. All right, and you can see here, it's prompting me for my secret credentials, which is, for those of you who don't know, it's Tridium Niagara, but I'm sure most of you do at this point. And from here, I'll be prompted with the standard configuration questions you would get on a new instance. So I'll hit next. I'll just give it a password, or a passphrase, I should say. Hit next, a new user. And that's it. We now have the platform running and we can connect it and we could load a station at this point. And from here, you would treat this platform just like any other. You would copy a station over, you would start a station, you would configure it any other way. Ideally, you would set your ports for your web service to something appropriate, but you would need to make sure that whatever you do in this case, that you've matched your security group, that you matched the ports open here. So you can see here in my security group, I've only opened port 22 for SSH access, port 4911, and port 5011. So enough for me to start a station and verify it's running, but I would open up my web port once I was ready, once I had a station running. You can see, and it's good to create these in advance, because if you're going to deploy multiple instances, you probably just want to select one security group and manage it that way. So were there, Mike, did you have any questions, or should we take questions about this particular deployment before we move to the next one?
No, let's go ahead. Let's roll into the next.
All right, for the next one, we're going to do something a little bit more fun. So we have 3 instances running now. These are 3 Linux instances, and we've managed to, we've set up Docker on it just like we did on the previous, but in this case, we're using Docker Swarm as our orchestration utility. So if we go back here, I have this running here, and we have something called Portainer installed. And this is just a way to manage the environment. You can do this at the command line, and there are some other graphical utilities for doing this, but Portainer is really easy to deploy, has a nice template for this. So if you're going this, you can deploy for Swarm, and it's very easy to use. So in this case, I've connected to my Swarm, and I'm running Portainer on my manager, and I'm running the agents on all 3 instances. So you can see here, I have 3 instances, N1, N2, N3. And I have my manager running on N1, and I have my workers running on N2 and N3. So they all have agents, but these are acting as workers. And what that means is we can deploy containers to any of these, but the manager is going to, when we deploy a container to the manager, it's going to look at all of the instances and try to evenly load it. So it'll start Niagara on the one that it thinks is the least loaded at the time. So we could have 10 workers, 20, 30, we can have as many as we want. And before we move on, one thing I want to note here is if I select one, I've added a label here. So if I had and the reason for this is when you deploy, you can specify a label as a constraint. And the reason that's valuable is, let's say you have a Docker Swarm with hundreds of instances, but perhaps not all of those instances are really good candidates for running your station. Maybe you need a lot of memory. So, and maybe some of them don't have it. So here I've added a node label that says Niagara capable, and I say true. And this is just me specifying on instances that in my Docker Swarm that I feel have the resources to handle a big station. I'm specifying this here. You could add additional labels, like you could have Niagara small, Niagara large. You could and specify true. And when you go to deploy this, and I'll demonstrate this here in our Docker compose file, I've specified the constraint, and it's looking for the label here that says Niagara capable equals true. So with that there, that means the manager will only deploy instances. This manager will only deploy that container to instances that have that label. It's a great way to limit who can run the Niagara container if you have a lot of workers in your Docker swarm, which you might, depending on your setup. And the same can be done in Kubernetes, by the way. So this isn't specific to Docker swarm. There's a similar way to handle this in Kubernetes if that's your preferred environment. So for here, this one's very easy. We have to create this on the station. So we just need to take this, and I'll go ahead and create this real quick. Let's go to our manager, and I'm going to create nano Niagara stack.yaml. So I'll create the file. I'll paste this here, save it. And we can see here that the file's there. So just in case anybody's wondering, we've already added the file. So now we're going to run this command. So the first thing I'm going to do is I'm going to make a directory. And I have on my Docker swarm, I have a utility running called Gluster, which synchronizes data storage across all of my workers. So that's how I'm handling to make sure if we start this Niagara instance on one worker and then it needs to move to another, that the station and all of the relevant data, including licensing, is still there. So I'll run these two together, make directory, Niagara 1, and we'll run this one. And you'll notice here, it's specifying the file niagara-stack.yaml, and it's going to name it this stack Niagara. So we'll go ahead and run this here. See, it's creating the service, and then it's going to start it. And if we go back to Portainer, it should start a Niagara instance here shortly. So we'll go back here. We'll go to Portainer, and we'll look at our containers. We'll be looking for one that says Niagara 1, and here it is. Under Niagara 1 is now running. And if we look over to the right, we'll see that it's running on, there we go. So we can look at the log file here. We can see it's now starting up. And so if we refresh this, we'll see it's going through the normal startup phase for the container. And we'll wait for that to finish loading. And then what we'll do is we'll go ahead and verify it's running. And then we'll shut down the server it's running on to see what happens to the container when we do this. Right, so if we were to look while that's starting up, if we were to look at the command line, we can see that it's created, the directory is created, but if I look in that directory, you can see it's creating a file directory that you're used to. So daemon, etc, logging, modules, securities. This is similar to what you'd see on any Niagara instance, and it's creating those under there. These are going to be available to all of my workers, and they're synchronized across all of them at the time of creation. So this means that if I stop this container on one instance and move it to another, within a couple seconds, not only will it be up, but it won't miss any data, or at least it will have all data related to the last station save. So it's worth noting, if you are doing this, it's probably good to have a relatively frequent station save time. Just see startup complete here on our container. And so if we go here to Swarm and we look at our cluster visualizer, this shows us we're currently running on the worker N3, we're currently running Niagara 1 here. So now normally what the manager will do is it will decide based on loading and other parameters and other containers you're running, it will decide which worker needs to run this. Now you can, once again, you can use constraints to dictate where it goes, whether it goes on a specific one or it goes on these three. But in this case, we just have two workers and they both have the same label. So it just decided on its own that it wanted to run it on N3. So we have Niagara 1 here running successfully. So the question now is, what if we shut down N3? Right, so here's N3. And I'm going to do something you'd normally never want to do, which is just shut it down in a not nice way. So we're just going to crash it. So sudo shutdown h now. This is going to shut down N3, and that server is now down. If we come back here and we look at our swarm, at some point the status for that server is going to fail. So if we refresh this or we're watching this, at some point this will fail here in the next few seconds. And when it does, the manager is going to see that that's down. And it knows that it has a requirement that it needs to run a Niagara instance, specifically the one we started, and it's going to try to find somewhere to run it. And since there's another there's another worker available with that label, it'll start it there. So we can see here, we're running, and let's go to this view actually. Let's go here, let's go back to the cluster view. And you can see here, this server is down, and you can see our containers already started on this one. And it's referencing the same file. So if I had already licensed this, if I had a station running, I only would have been down a couple seconds. And these are, and keep in mind, these are running on pretty light instances, one CPU, one virtual CPU, and only 2 gigs of memory. And this is able to, and we're doing this without a problem. So this is a pretty easy thing where you could, if you have uptime as a requirement that you need to keep your Niagara instance up, or you need to keep multiple Niagara instances up, this allows you the flexibility to have a lot of small instances running and have the manager or multiple managers move them around and kind of load them up based on your needs. You would, of course, need for users logging in, you would want to run a load balancer. And what a load balancer would do is it would detect which one of these was actually running your instance, and it would always point traffic towards the right one. So a user would never have to pick an IP. The load balancer would automatically know which one was running where, and it would point them towards the right one. And that's not something we're covering today, but it's a very easy step, and we could talk about it in maybe in a later session, more advanced one. So Mike, did you have anything you want to touch on before we move on to the next one?
There was a question in the chat about, let's see if we can answer that live, load balancing using AWS Elastic Load Balancer, and also web application firewall such as Cloudflare or additional services to harden for security and certificate management. If you could work that in here.
Absolutely. So to answer the first question, Cloudflare, we already use it quite a bit internally. So Cloudflare, yes, inside of a Docker Swarm, inside of Kubernetes, also just on single instances. I'm a big fan of Cloudflare. So we're very comfortable with it. And I do typically use it as a container, and I route it through an overlay network here. So I would be running the Cloudflare container in my Swarm, and I would have that point to the load balancer and in turn know where the containers are running. So Cloudflare has some ability to do that on its own, but yes, to answer your question, well-versed in Cloudflare, and I think there's some fantastic utilities there, especially around security. So Cloudflare's a hard yes. And then what was the other question, Mike?
The
load balancer?
And then there was a question about web application firewall. Yeah, and load balancer.
The load balancer in AWS is good to go. We didn't show it here simply because it's a little bit more of an advanced deployment, and I felt that Docker Swarm was if you wanted to start out and play with this, I think Docker Swarm is something, because you can do that on one laptop just with a few instances, a few VMs. So it's really, Docker Swarm is a really easy thing to test yourself. But yes, we have tested and it does work. In fact, that was almost going to be this demo, was using the load balancer in AWS. It just, like I said, turns out it wasn't as approachable to a larger community. So we felt like we wanted these demos to be things that you could watch this later, and with a little bit of extra information that you could potentially just go and play with and do yourself. So, but to touch on that, maybe that's a good either a document or maybe another webinar later. But yeah, AWS, it does work though. Yes, to answer your question, it absolutely does work.
All right, we've got about 6 or 7 minutes left for demo. I think you had one more you wanted to show off, and then...
yeah, a quick one. So this is something near and dear to me. So this is an Apex container, and we wanted to show just to have at least one more deployment and showing the 3 different types of deployment, because we talked about an on-premise. We talked about just a supervisor on premise is basically a supervisor in the cloud, or a supervisor at scale where you have it using some type of orchestration utility to run it. But there is the occasional use case for having something in a more constrained environment at the edge on a controller. And in this case, we're going to show you how easy that would be to do. So here I have no containers running, and we're going to add one. And this uses Docker. It's just for our controller, we use the standard deploy options. We don't have anything as fancy as Docker Compose just yet. So if you look at these, they are effectively the same thing. They're just a little bit more in detail. So you can see I have the same ports that I normally would. I'm mapping those ports to ports on my controller that I think for whatever I need to do, I want to map those there. And then you can see I'm also mounting my volume here. So I have my Niagara home/Niagara and same. So the same thing I'm doing in these other commands, same thing I'm doing here, and the exact same thing I'm doing here. Just once again, another format to do the same thing. And here, I'll grab this real quick. I'm going to copy this. And you'll notice it's all pulling from the same registry. But this time, instead of AMD, I'm pulling the ARM image because the controller is ARM64. So I'll name it, and then I'll paste my command in. I'll hit save. It'll create the container, and we'll hit start. Okay, container's running, and let's check the log to see. It should start to update, and we should start to see the normal message traffic we expect when you first start a container. And that's just doing things. So at this point, I can connect to this with my platform. So I now have, in a few minutes in live demo, we've now done one cloud supervisor. We've done a supervisor using an orchestration utility, and we've also done one on a controller, which I misspelled. Apologize for that. So Mike can punish me later. I just noticed that. That's unfortunate. So
I thought you loved Niagara.
I did too. I wish I could say that's the first time I've done that. It's absolutely not.
I would like to say I've never misspelled Niagara either, but it's happened. All right.
So at this point, you wanted to go back and do licensing, perhaps?
Yeah, let's run through the licensing, and there's a couple of answers in the Q&A that I'm going to mix in as we go through this. So a couple questions about what happens if the Niagara instance can't dial home. There are parameters we've added to the license file, which indicates the check-in frequency and the number of failed check-in attempts. So what happens when it reaches that maximum timeout is it shuts down the station. We're being very liberal with this as we roll out this new product. So right now it's checking in every 12 hours, and it will shut down the station after 30 failed connection attempts. So that gives you a 15-day window of failed check-in attempts before it shuts down the station. And then there's some questions about, intermittent connectivity. Really, this is, intended for cloud supervisors and devices with that reliable connectivity and always being able to hit our entitlement server. So if it's a situation or a deployment where you've got intermittent connectivity or the device is not always connected, this may not be the best option, but we are working on future enhancements and different offerings down the road. Again, this is just our initial rollout. So if this isn't the perfect fit for you, we'd love to hear additional feedback on that and enhancements we can make in the future. Another question that came in the chat that I wanted to answer live is somebody asked about the host ID, because this is virtualized and abstracted, and typically a host ID is generated off of the CPU or the hardware that it's running on. So you'll notice Robert's in the licensing manager view here. You can see it's got a very unique type of host ID. We're calling this the NRE ID, which is your Niagara Runtime Environment ID, and this is generated via the JRE that's running on this. So what Robert's doing here is he's gone into the license manager view. This should be very familiar and comfortable to all of you. Can you go back a step, Robert? I think I missed it.
Yep.
Yeah, so you'll see, you'll see in the bottom there that it's an unregistered host ID. Please register. All right, let's go to register.
Okay.
And now you'll see an additional dialog. Oop, maybe it's not on this one. I thought it was on the subscription license. It must already detect that it's a subscription instance. If you're licensing another Niagara instance, you may see the device registration dialog pop up with the additional radio button for register subscription instance. At the time being, this is the only valid subscription instance that you're going to register. So you would go into Niagara Central, you would place your order for subscription licenses, which will generate your subscription license key. So which is what Robert has here. And he's going to
already. Yeah.
Yep. So here are all of his keys that are not bound to licenses. So he's going to just pick a license key that he wants to bind to a Niagara license. So he comes in here, goes into registration, and he's going to paste that subscription license key in here.
Let's hope that works. There we go.
There we go. He's going to hit that URL that's in the verification, which is a hyperlink in here. So you can click on that. And this has a multi-factor authentication to make sure that you are the one with the subscription instance. This is you, and you need to be logged into your Niagara Central account. And then you're going to
So I need my code.
Yeah. Yep. So if any of you are familiar with the way you authenticate Netflix or Hulu or something along those lines, it's very similar to that. He's going to take that authentication code, paste it in there, and connect.
Oh, we talked about this. I did this. Was my fault. It timed out on me.
All right. He's going to allow that device to claim that license.
Hit continue.
Hit continue. So a little bit different workflow for licensing a subscription instance, but he should hit OK here. And now it's going to pull that license down from our licensing server.
And I think one of the things that's been popular so far that we really like is that this is entirely portable. So if you back up your container and redeploy it with the volume, it maintains its licensing.
So that is the new subscription licensing workflow. So not dramatically different from what we have, but just a couple more steps in the process to license a container instance. Chris asks if there are any plans to automate the licensing process to be more hands-off. Yes, we are working on that as an enhancement. We understand that if you're deploying at enterprise scale, you would probably want to automate more of the licensing and the binding process of this. So yes, we are working on future enhancements for easy scalability. And Robert is highlighting there what the parameters are set to for the subscription mode, which is the valid check freaks. That's how often it checks in, and valid check retry limit. So after it goes past 30 12-hour check-in, failed check-ins, it will shut down the station.
So this one would be 15 days, Mike?
That's correct.
Okay.
So we do have the flexibility. We built it in as a license attribute, so we have the flexibility to tailor it as well. And again, working on future enhancements to interact different ways, license containers different ways. All right. Anything else on the demo, Robert?
There was one we didn't get a chance to
oh yeah,
talk about,
yeah,
but
just show up Grafana.
I did want to mention, yeah. So when we were running in, because it kind of ran short time, when we were running in a swarm, we can run some nice utilities to kind of get some visualizations on how many resources we're using while running these containers. And this is really easy to do and can be deployed as part of your Docker Swarm. The same thing can be done in Kubernetes, so it's not specific. But I wanted to show this because if you're running multiple instances, you can make dashboards like this very easily. And then you can come in here and we can specify our container. In this case, it was Niagara 1. And we can get, this one's only been running for a short period of time, but if it was running over the course of days, you could get a lot of data related to the performance of that container. And this helps you understand how the manager is deciding where to deploy these containers to. So you can see here, we're using about 400 megabytes of memory. We have some cached, and we're not using any CPU usage really, because there's not a station running currently. It's just the platform. But it's worth noting these are deployed in a single step. So if you were doing this, I went to app templates, and I just hit swarm monitoring, and I deployed that with the username and password, and that's all that was required. Once it targeted my manager, and that was it. So you can tell there's some very easy to use tools to, whether locally or in the cloud, for you to try and play with this and see the value in using a container versus using a traditional deployment. Especially for this, we have had a lot of customers ask about ways to have redundant setups or have a more fault-tolerant Niagara deployment. And this is one really easy way to do this. If you don't have to have these instances be in the same data center. They could be in different data centers.
All right, Robert, are you still there? Your audio cut out. I think we lost Robert. All right, while we wait for Robert to come back, I will roll into some additional Niagara resources and materials available to everyone. Always like the opportunity to promote our Tridium University, where you can find free e-learnings and register for courses and classes, both virtual and in person again. And we will get some resources up here regarding Containerized Niagara as well. And I mentioned earlier the TridiumTalk series. If you go to tridium.com, services and support, and the events tab under there you will find links to all of our previous Tridium talks. Again, this is just a number in a series highlighting the Niagara 413 features. Chris has done a number of great 413 overviews. So I strongly encourage everyone to check those out. And we also got our Niagara Pro Tip series on YouTube, hosted by the one and only James Johnson and Kevin Mamajak. All right, Robert, are you back online for some Q&A?
I am. I am.
Okay, that was
the danger of moving. It's a little bit.
All right,
Perfect.
So we've got about 9 minutes left. Let's see how many of these we can get through. If your question is not answered here on the call today, we will have a transcript of the Q&A posted alongside the video. The video should be available by the end of the week, and then the transcript should be available shortly thereafter. So if we don't get to your question today, please check back on the website and see your answers answered there. Okay. So Keith asks, as an app service developer, does this allow us to not require a JACE? Looking at moving some dev resources to cloud hosting and having a physical requirement for a JACE is an impediment. So I don't see any reason why you would not be able to utilize Containerized Niagara for development and testing. Robert, you guys are doing that today, right?
We absolutely are. It's my preferred, so absolutely we are. So I agree with that. Unless it's specific to a serial port or some hardware application. Outside of that, I think it's fantastic.
Okay. Jacqueline, I know there were a number of questions on the chat about demo licenses and the ability to use this for developer tools. Any comments on that?
We're certainly planning on adding a demo SKU to be able to work with containers. I think the question is whether or not it needs to be a subscription or whether or not we can use the standard kind of method of licensing like normal demo licensing. But the key thing is the container will still need to talk to the entitlement server. So it'll still need to call home either way, but we will be sorting out a demo SKU for that.
Thank you so much, Jacqueline. I've got a question here from Gregory about the cloud supervisor model we presented, best practices and Tridium advice. Yes, as we roll this out, we plan to put together a best practices document, best ways to deploy it, best ways to secure it. And then Robert, for you, do you have advice on securing the network communications from the building to the cloud supervisor?
We are coming up with some documentation around that, and for obvious reasons, we definitely recommend, even if you are using something like BACnet SC, which has some decent security level inherently, we always recommend using a VPN or an overlay network or some type of network infrastructure that adds an additional level of security. To that, we have a lot of customers who run instances in the cloud right now, not necessarily containerized, but standard Niagara instances in the cloud. And one of the struggles people usually have is what is the right network infrastructure to really keep the latency down, but to have the security level you need. So I don't want to point out any particular technologies, but you definitely shouldn't rely just on, say, for instance, BACnet SC. While that is secure, you still need to from the building to the cloud, you still need one layer above that as well. Some type of general network security. So, but we'll also generate documentation around that for our deployments, but they're probably going to mirror what your team does, I'm sure of it.
Great. See a question in here from Chris. In previous versions of N4, only on Linux, Red Hat, and Ubuntu were the supported OSs. Those are still our officially supported Linux OSs. While Robert was demoing this in Amazon and Amazon Linux, the core container, the base of it is an Ubuntu image, base image. We are considering additional Linux distros down the road, but nothing firm on the roadmap. All right. An anonymous attendee asks, can you explain more about the Docker registry in Niagara and is it customizable? So the Tridium itself will not be hosting a registry. We will be distributing the containers to our OEMs and resellers, and then some may or may not set up a registry or repository. Robert, what is good? Can you talk some to Distech's plans on how you would handle distributing the container to your end customers? Or is that still a work in progress?
It's still a work in progress, but I can assure you that there will be, from our perspective, there will be a customer facing registry. How open that is up for debate, depends on the market and use case. But even as of now, even in beta, we use the registry to demonstrate. And creating a registry and populating it with images is actually a very easy step. There's a lot of tools out there, from DigitalOcean to Azure to Vultr to AWS to Docker has a container you can run on your laptop to create your own registry. So there's a lot of pre-built tools that are out there that you can readily leverage and use. And really, it's just, it's a poor analogy, but it's almost like an FTP server. It's just an endpoint where when you deploy your container, that it knows to pull the image from, and if it needs updates or you want to update it with a new image, you push it there, because that's part of the strategy with the portability of containers and Docker in general, is that you can update these images and that your target environments can pull them when appropriate, can pull and run those updated images. So it's don't let it seem like it's a huge technical burden. It really isn't. And Distech will have a registry in the future. I just don't know right now what that's going to be and what images will be there on day one, but there will be one for sure.
Yeah, and we are testing here as well. I've done both the registry approach. We have an internal one for pulling and updating the containers. And then another method is supplying the container in a tar file, which you then pull and load onto your machine and spin it up from there. But Robert did touch on a very good point there, is that the intention and part of the beauty of containers is being linked to a registry and knowing when there's updates and when they're published. But those are things that we are both focused on and looking at in the near term to roll out. There's a question in here. I'm going to try to answer this. Are these containers or the actual Niagara server? If they are containers, what are the usages? Not really sure 100% what the question is there, but the Niagara image in there is just like you would run Niagara today. It's the full stack of Niagara. You can run it as a server or, as Robert demonstrated, on an embedded piece of hardware. And it is it's the same base container image, whether you're deploying on server or embedded hardware. It's got a lot of the modules already built into it. And really the fundamental difference there is licensing and how the containers are licensed. Any comments you'd like to add on that, Robert?
No, I mean, you kind of said it best there. That's it's not different. It's just, in fact, from my perspective, it's a little bit better in most regards, because once again, it's portable. You can back it up, you can redeploy it. I mean, it makes it easier for you to increase your security threshold, just because the backups you make they're smaller, they're the size of your Niagara instance, and when you redeploy them, your instance is back, right? So that's how Docker Swarm was basically doing it, right? So it's a big improvement on all regards.
Okay. Brody asks, are Kubernetes and Docker Swarm roughly the same thing?
Yeah, there's some slight differences, but yes, from the perspective of the container, yes. But there are some differences in how you would deploy. But it's like hypervisors. There's VMware, there's KVM. There's a bunch of them, but they're effectively doing the same task. Right? There's just slight differences in how you deploy. Same thing here. So, like I said, we just showed Docker Swarm because it's a little bit more approachable at the beginning. So if you're new to this and you just want to play around with it, Docker Swarm is a great start, because you can take a standard Docker Compose file and just use it. And if you already have Docker installed on a couple locations, you can run it. So it's but if you want to start straight with Kubernetes, there's no problem. You would have just as easy of a time. It's a very good platform.
Okay. Thanks. There's a lot more questions in the chat. I'm going to err on going over a couple minutes just in the interest of answering some of these, because I think it's good to have them answered live. Matt asked, have Niagara updates via containers been tested yet? Yes, they absolutely have. Robert, I'm going to turn it over to you, to your experience. I know I've sent you a dozen different updates to the container images. So
absolutely, and I was running the station. I have one that's been running that we didn't show, that has a station I use, and I was able to load new images, and there was no issues at all. I referenced the same folder, and the image started. So for me, it was just like if on Windows, when you do a new Niagara installation from say you went from 4.10 to 4.13 or 4.12, and it prompts you, do you want to copy everything over, right? That prompt you get during installation. It's just like that, except much faster. We're talking a couple seconds, because you pull the image, and then when you start it again, it uses a new one. So the update process is very fast, and it works fine, just like you'd expect on your Windows server or something similar.
Yeah, and when you push an update to the container, all of your Niagara licensing, all of your properties files, all of those persist. So it's just a matter of pushing the updated container into the running instance.
Yes.
All right. Let's see. Someone asked, if you need an on-prem serial connection, could you use a BACnet gateway or some other network device or driver? I know if a lot of this, if you're running BACnet MSTP, you could do a BACnet MSTP to IP converter and bring it in over an IP network. I'm going to ignore the part of the question about eliminating the Jace, because I'm the hardware manager, and I think there's always a place for a Jace in a building. So. All right, let me just scroll through, and we'll end on one final question here. I think this is a good one. Robert showed a redundancy failover scenario. What about running multiple unique and different stations with different ports and stations in a swarm?
There's no issue. You'd have to coordinate with your load. When you set up your load balancer, if you're pointing those instances by however you're referencing them, if it's by a domain name, or if you're doing some type of other resolution, but you can have multiple Niagara instances, all with ports to 8443, 5011, 49. There's no issue. We could start another one now. It's just when you want customers to hit those endpoints, because you don't want them to have to know the specific IPs of every worker. That might be fine for whoever's setting it up, but for them, you need to work on your load balancer to make sure that you can route them to those unique instances. And there's a lot of ways to do that with load balancers. There's a number of them you can run, like Nginx Proxy Manager, there's Traffic, there's a bunch. So yes, to answer your question, you can definitely do it. And that's definitely how I see using Docker Swarm, is with multiple Niagara instances. But that's probably something we could showcase later with another webinar, or maybe a documentation, is how would you set up the load balancer?
Awesome. All right, we've gone a couple minutes over, but Robert, can't thank you enough for your time. You've been a tremendous partner and a great asset to throughout the journey we've taken for the proof of concept and rolling it out and doing these early access demos. It's been a great pleasure working with you, and thrilled to have you on today's call. Really appreciate your time. I know you're in the process of relocation, so I especially appreciate that you took the time while you have no furniture in your house to take the call today.
I appreciate it, and thank you very much for inviting me along on the ride. It's something that's near and dear to me. I've had a great time, and I can't thank you enough for letting me participate.
Yeah, thanks. So you can see my email address on the screen, and Robert is in witness protection programs, so he didn't want me giving out his email address. So if you route it to sales@distech.com or sales@distech-controls.com, they can get it forwarded on to him. I don't know if you're really in the witness protection program. So.
No, it's just hiding from all my admirers. That's all.
All right. This concludes Containerized Niagara and subscription licensing. Again, feel free to reach out to me. And check out the website, share the link, share the recording, and the Q&A answers will be posted soon. Thank you, everybody. Have a great rest of your day, and we'll catch you on the next one.